I know what you're thinking. It's not what it looks like. It's all PewDiePie's fault. PewDiePie's fault? Well, okay. So he's building a council of AIs, or he built a council of AIs. He also hangs out on our forum. Hello, welcome. Be glad to help, whatever you run into. This is my council of AIs. It has 4 RTX Pro 6000s. But really, that's not what I'm here to talk about. This is not about AI at all. This is about a long-standing thing that we've been doing on this channel since before the AI thing, which is putting PCIe lanes in places where they don't belong. Because PewDiePie ran into the same problem that I ran into. And yeah, this is not a super modified mining rig, but let me start at the beginning before we get too far off track. So we've got some really sort of like, this is a Threadripper machine. It has 96 cores. It has a 3D printed bracket for the memory. I have 512 gigabytes of memory from G.Skill in here, thanks G.Skill. Dual 1600 watt power supplies because we're running all 4 of our GPUs at 600 watts. There's 384 gigabytes of total VRAM here, so just shy of a terabyte of memory for this whole system, about evenly split between the CPU and the GPUs. And physically, the GPUs do not fit together. Like, you could try to stack up 4 of these 600 watt behemoths, but even having the 2 down there close together, I don't really like that. And old mining rigs, when you're mining cryptocurrency, they would only use 1 PCIe lane. You see, when you're doing cryptocurrency stuff, all of the stuff happens on the GPU, not the CPU. And so you could just load up the GPU and let the GPU do its own thing. So the GPU doesn't really need a fast connection. If you look at old cryptocurrency mining stuff, it uses a not super modified USB link, which runs at like PCIe Gen 3 speeds. The world has moved on from PCIe Gen 3, it's PCIe Gen 5. And I know what you're thinking, we could just use a ribbon cable. A ribbon cable such as this. I mean, it's labeled PCIe Gen 5, it can do Gen 5, right? No, there's so many people in the audience, like DisplayPort cables, USB cables, they're like, it's a certified cable. Oh, sweetie, that doesn't mean anything. That means nothing, literally nothing. This has a label that says PCIe Gen 5, and it can do PCIe Gen 5 in some scenarios, but there's no electronics on this cable, so I'm immediately suspicious of it. Why would I be immediately suspicious of this cable? Well, you see, this motherboard that has all PCIe Gen 5 slots, it's all 16 lanes, that's the magic of Threadripper, right? It brings us all these PCIe lanes. Threadripper Pro, I mean, 128 lanes plus the chipset lanes, it's just crazy. The problem is that PCIe Gen 5 is so fast that so many bits stack up in this amount of wire that you really lose some signal integrity through the wire and through the connectors. And so on a motherboard like this, our ASRock WRX90 or even our Asus WRX90, the slots that are on the bottom part of the motherboard have extra electronics to redrive and retime and clean up the signal, depending on choices that the board designer has made. Servers take it even a step farther. They go even beyond that. And so you can't just use a ribbon cable. If you use an extension cable like this with a setup like that, you're in for a bad time. I mean, PCIe Gen 5 at this length, it doesn't really, give you a ton of clearance in terms of fitting more GPUs in there for cooling reasons. And this doesn't really work all that well for PCIe Gen 5 anyway. Like, it can work, but I don't trust it. So it's such a problem that I actually want to carry a product on the Level 1 Tech store that is our own PCIe Gen 5 interface. And so we'll have the card edge connector, and then these little chips do retiming and redriving. And this is like Babby's first version of it because I don't want it to be ludicrously expensive. But what we're actually using here is hardware from LR-Link and Broadcom. See, Broadcom has got the monopoly on a lot of these interfaces. And there are other up-and-coming companies like TI and Phison and ASMedia that have their own redrivers and retimers to take the PCIe signal and send it on. And that's what we've got here. We've got an LR-Link interface card that's taking our 16 lanes, and I've configured this slot on the bottom to run an X8, X8. And then I've got PCIe Gen 5 MCIO cable going out to LR-Link PCIe slot PCBs. That's how this is working. But you can't just do this kind of a thing with passive cables. You can buy them. You can buy passive cables. You can buy the adapter boards and the cables and stuff. That's only like $15, $20, $30, something like that. But that adapter card can run upwards of $1,000 depending on what it is that you're getting. Now, obviously I'm targeting a little less than $1,000. And there are others out there like C-Pain who are doing this same kind of thing, but I want a piece of that market. I want in. And so, you know, I don't know. I don't know if it's, I don't know what that looks like exactly, but not necessarily for the AI side of things, but just for the fungibility of PCIe lanes. In our case, we're moving stuff around from a PCIe standpoint because cooling. But really, in a world where desktop motherboards have all M.2 slots and not enough PCIe slots, and it's just PCIe lanes, we can readapt those back into PCIe slots with these kinds of adapters, as long as they have redrivers and retimers. And we've looked at that before. You might notice that I've got a Memblaze M.2 just hanging out on the desk. Yeah, we should really mount that. But that is connected to an MCIO header on our ASRock motherboard with a PCIe Gen 5 rated cable into our drive. Now, ASRock, for their board design, they have redrivers and retimers to clean up the signal. But this cable length is pushing the maximum limit of what we're able to do with PCIe. And this is also 4 lanes. Like, you could adapt this back into a PCIe slot, but then your PCIe slot is only going to be 4 lanes. LR-Link has another solution. The other solution from LR-Link is our PCIe 5x16 into 4 8-lane MCIO connectors. So there's 32 lanes of PCI Express out and 16 PCI Express lanes on this side. Look at the crazy stuff we've had to do because of PCI Express signaling. The card edge connector is different. It has this weird pattern on it. And this is because we need every little bit of signal to noise ratio that we can possibly get to maintain PCIe Gen 5 signal integrity. When you've got a motherboard design where some of the slots are straight into the CPU, the ones at the top of the motherboard, and some of the other slots at the bottom of the motherboard might go through redrivers and retimers, your only option may be that really expensive Broadcom chipset. And that's this, and that's why it has a giant heatsink and a cooling fan on it. But this gives us 32 lanes. It gives us 32 lanes of Gen 5, but the important thing with that is that you can also mux those connectors. It gives us kind of a Lego-like experience in terms of being able to cobble these things together, because you might be connecting something where you don't want to give up any lanes. You want 16 lanes and 16 lanes, and they're not using all of the bandwidth at the same time. Or it might be 16 lanes of Gen 4. So if you're connecting 2 Gen 4 devices that are fully X16 with both groups of connectors, out this side it's PCIe Gen 5, that's perfectly okay. There's no bandwidth contention there because PCIe 5 is twice as fast as PCIe Gen 4. And so this is a really awesome, insanely handy little thing, even though it is, you know, $1,000-ish. So you can take this thing into this cable and into this thing, and now I have one of my PCIe slots hooked up with 8 PCI Express lanes into this thing. And this is full Gen 5 bandwidth. If I hook up a second cable, I will have 2 X16 physical slots. And so this thing, I've got 8 full lanes into my first PCIe slot. If I hook up a second wire, I will have another 8 lanes into my other slot. The boards here could also support 16 lanes. Those support 16 lanes. So if I connect 16 lanes with 2 cables to my RTX Pro 6000s, they're gonna have full bandwidth all the way back to the card. Now with only one card, it's still gonna share 16 lanes, but I got 2 cards. I could use half of my lanes on this card, half my lanes on that card, and then still have each GPU with 16 lanes all the way back in a perfectly redriven and retimed signal. I'm also able to use my own card. And so my own card, it supports bifurcation, but it's much more limited. It's a much simpler design. It is designed to solve a different set of problems. But I could use this with this and get 16 lanes, or I could turn on bifurcation in the BIOS, as I've done with this setup, and this thing will happily drive 2 X8 wide PCIe slots, and that gives me the ability to relocate the GPUs farther away and also run them at X8 lanes so that I've still got a reasonable amount of bandwidth. So this is 4 PCI Express lanes, and that goes out to our our U.2 connection for enterprise drives, and this works with the ASRock motherboard. This is 8 connections. This type of connector is called an MCIO connector, mini cool edge. And so 8 PCIe lanes, 4 PCIe lanes. So you can use 4 of these cables, it's not very convenient, but if you want 16 PCI Express lanes, you only have to use 2 of these cables, and then you can break out and go to 16 lanes. Now this particular board is designed for 8 and 8, so 8 lanes here, 2 cables. Yeah, so I can run 4 GPUs at 8 lanes off of a single X16 PCIe Gen 5 card. And there's no bottlenecking if I'm using Gen 4 GPUs. And for a lot of AI workloads, because the usage is bursty, there's not really too much stepping on toes, even at PCIe Gen 5 speeds. So when a GPU, just one of the GPUs needs to run at Gen 5 speeds, it'll run at Gen 5 speeds. You get the full x16 bandwidth. It's pretty awesome. Now this is PCIe devices. What about U.2 or Kioxia CM7? These are some of the fastest PCIe Gen 5 enterprise grade SSDs that you can get. Yes, you can go from this 8-lane MCIO header to not one, but two of these. LR-Link is one of the only companies that I've been able to buy these from and have them actually work reliably. And look at this. This is an absurdly long cable. This is really pushing the limits of signal integrity. This is an 8-lane wide MCIO connector. There's no desktop motherboard that has this kind of connector, but a lot of the times you see this on server class motherboards. When I built the HL15 Home Lab around the ASRock Rack Genoa motherboard from AMD, it had several of these headers. I could use them for mechanical hard drives for SATA because the motherboard supports that, or I could use them for PCI Express for NVMe, and that one connector gives me 2 drives. So I could run 2 of these Gen 5 drives for my metadata special device, or another, PCI Express type option at the full 15 gigabytes per second. And that really is something nice for like my home storage server usage scenario. Basically, all of this is just to say that PCIe lanes are fungible. You can take your PCIe lanes and allocate them however you need to. And this is also why server motherboards a lot of the time won't have a lot of slots. They just have connectors. But the connectors are designed to go from the connector to cables like this. And then the cable will give you a drive, or the cable will give you some slots, or the cable will be something at the front of the machine. Maybe it'll be CXL adapters. Remember our Gigabyte server with its CXL, all of its PCIe lanes go to the front for CXL. It's not even PCIe lanes at that point. CXL is a superset of PCI Express, and your bridge chipset has to support CXL. Guess what? LR-Link has products that support CXL signaling protocols, so you can put memory devices behind your PCI Express slots. Mine won't do CXL. They're not designed to do CXL. This is solving a slightly different set of problems. But it is, it doesn't need a heatsink and a ridiculous amount of cooling, so yay! And it does have an absurd number of dip switches for configuring how much you want to redrive the signal. And this is awesome, really, this is good. Like, I'm getting there, but is this like, I should carry this on the Level 1 Tech store because this is really absurd. Like when Pewdiepie was building this, he wanted to build something with single slot wide GPUs. These RTX Pro 6000s have 96 gigs of VRAM, but you can hard partition them into 4 different GPUs. They'll show up in the system like as if they're 4 physically separate GPUs. That's called multi-instance GPU. So you have 4 24 gig GPUs per GPU. This system, if these were all configured for MIG, would show up as 16 GPUs. I can have a council of AIs that are running 16 24 gig instances, and we can really do a lot of council of AI stuff with that kind of a setup. But it's really all about the flexibility with PCIe and PCIe devices and doing fun, interesting things with PCIe. The thing that I think is missing, the thing that I really want to see, is the cost to come down on this kind of a solution. Because this kind of a solution actually would be the most amazing thing for AM5, for AMD. You take 16 lanes, and you got 32 lanes out the other side. This is what the motherboard chipset used to be, and this is what the motherboard chipset still kind of is, but instead of for high-speed devices, it's for low-speed devices. You want your GPU for latency reasons to be close to the CPU. You want your main storage for latency reasons to be close to the CPU. So, AMD is kind of between a rock and a hard place here, but this kind of a device with like 8 Gen 5 lanes giving you 16 Gen 4 lanes or 32 Gen 3 lanes for all of your peripherals mean that you wouldn't be stacking up any kind of bandwidth contention, because those are the same bandwidth numbers. 16 lanes of PCIe Gen 3 is the same as 4 lanes of PCIe Gen 5. And so a smaller version of this on a desktop or a serverish desktop motherboard could give you a lot of PCIe lanes for older peripherals or slower peripherals that have more PCI Express lanes, like 25 gig network cards or whatever, but you're still using a not insanely expensive CPU, like an AM5 based CPU. But yeah, I don't know. This is like where we are, like servers and server stuff and all the server related things have already figured out all of this. The only reason that I want to share this is because we're doing DIY off-label stuff and experiments. And so like I can experiment and say, how much of an impact does it really have having 2 of my insanely fast GPUs only connected with 8 PCI Express lanes? It makes a little bit of a difference, but it doesn't make a ton of difference. In higher end chassis, things like this, there's 8 GPUs connected together. And it became such an issue for NVIDIA in the architecture of their systems that they actually combined the chipset that does the PCIe bridging with the one that does networking. So on a modern NVIDIA, like an actual AI computer with 8 of these GPUs in it, well, not these GPUs, but this architecture for those GPUs, in that chassis with 8 of these, the network card and the PCIe bridge are the same chip. And that is for speed and latency and everything else. And it's actually a slower connection back to the CPU. That's PCIe Gen 6. So the GPUs connect to PCIe Gen 6 and the network connects to PCIe Gen 6, but then that amalgam, that fabric, connects back to the motherboard with PCIe Gen 5. It's slower. And that is kind of mind-blowing and kind of insane, but also like we need stuff like this for experiments and fun stuff, and PCIe lanes are kind of fungible. And this is all PewDiePie's fault. It's all PewDiePie's fault, because it was like, okay, how do I do this? And I can't, these GPUs put out too much heat. I have to get them far away. And if I want them far away, I have to have signal integrity. And if I want them far away and I have to have signal integrity, I'm gonna need LR link devices to do it. Or at least some kind of redrivers and retimers, because the ribbon cables of yore, this is a recipe for disaster. Like, why doesn't it work? It mysteriously fails. It mysteriously has problems. This is why. This solves the problem. Anyway, that's enough rambling and ranting and talking about PCI Express lanes and how everything is connected together and PCIe topology. But yeah, I don't know. Is this a product that should be on the level 1 store? Like, should we carry this on the level 1 store, this kind of stuff? I don't know. I kind of think there's enough of us, of a very normie pleb is constantly commenting on this kind of thing. Not a fan of Broadcom for a lot of reasons, and neither am I, because Broadcom is not interested in these small corner edge use cases. They're not really doing a lot of debugging for these small corner edge use cases, but it works. Look what I have wrought. Yeah, anyway, I'm gonna list level 1. If you have any questions about PCI Express and PCI Express related accessories, I am really excited about that. PCI Express was originally designed as a server-to-server interconnect, not for peripherals, but like so one server could talk to another server at high speed. But this is where we are now. If you have any questions or anything about that, I'm one of the level 1. You find me in the level 1 forums. Let's hang out, chat, whatever. I don't know.